Okay, so question 1, I'm given an initial velocity, I'm told time is 5 seconds, and I'm given the final velocity after those 5 seconds, and it says that I can assume constant acceleration. So that means I can use my Suvat equations. So okay, so the initial velocity is 2, 6. I'm going to write its column vectors, just whatever you prefer is fine. Time is 5. Final velocity after 5 seconds is 9 minus 2, and I'm trying to find the acceleration. So I'm going to use v equals u plus at. So 9 minus 2 is 2, 6 plus 5a, t is 5. So if I subtract this vector from 9 minus 2, I'm going to get 7 minus 8. And then if I divide through by 5, I'm going to get a is 7 divided by 5 and minus 8 divided by 5. And then I'm just going to give that back in the same form as given in the question. So 1.4i minus 1.6j, and also give the units. Okay, so part B asked about was talking about its position. So it wanted its final position. So its final position is going to be related to how far it travels to its displacement. So go back to my Suvat equations. And I've actually got everything now I need to find S, but I'll stick to the information that's given to me in the original question. So I was given 2, 6. We're still talking after 5 seconds. So the final velocity is still 9 minus 2. Assuming I've got A correct, I do now know the acceleration as well. But just in case I made a mistake in A, it's a bit safer to use the information they've given me in the question. So I'm going to use S as a half u plus v times t. So the displacement is a half of u plus v. So that's going to be 2 plus 9 and 6 minus 2, 4 times by 5. So my I component is going to be 11 times a half times 5. So 27.5. And my J component is going to be a half times 4 times 5. So 10. So that's its displacement in those 5 seconds. But if I want its actual position, it didn't start at the origin. So I need to take that into account. So it's quite straightforward. Basically, if you think about, if you're starting at the position vector 3, 7, and then you're moving 27.5, 10, where are you going to end up? Well, you're going to end up at 3, 7 plus 27.5, 10. So you're going to end up at 30.5, 17. And again, let's just write that back as an I and J vector.